Alrighty, Tommy Reed here. I want to show you some updates. I'm actually making a new hydroelectric liquid fuel turbine engine. Basically, you might say it's based on the Clems with all the research I've done, but this is actually something a little bit different with all the research I've done. This pretty much it's a power system. It will use natural gas as the main provider for the extreme high pressure. We have our containment vessel. Still working on it. Basically, what I'm doing is modifying a combustion chamber right here. Basically, a overhead valve of a 5 horsepower engine. And pretty much what I'm doing is just doing some experiments right now. You get everything all hooked up and start priming the system. And pretty much what this is it's a very advanced concept using thrust instead of the pressure or compressed air that is actually increased due to the heat ratio of expansion. So we're using fluid, which has a much greater push through thrust than air itself. So it actually rotates inside. There's a couple of jets in here, and what those jets do is actually cause it to rotate. Think of the old sprinkler systems where they would actually turn around. Well, this will actually get up to speeds top speed is around 7,000 RPMs. The amount of fluid that it's going to use, it's already pre-calculated. So I already know all that stuff. I have my high side on this side, my low side on this. And what that does, that allows me to pull vacuum and also pressure, because I need both. I have to keep this extremely under a vacuum, and that's due to cavitation, because cavitation does occur if it is not in a vacuum. It is a complete closed loop system. It's pretty much going to deal with a lot of thermodynamics, kind of fluid, depending on the fluid itself. But overall, I should have this up and running pretty soon. A lot of technical stuff I have to go through, a lot of math. But overall, the pump itself does not drive the system. Actually, all this does is move the fluid where I want it. And basically, we have these little containers right here, combustion chambers, which is basically almost an accumulator. So it stores the high pressure from the combustion itself. Combustion could be anywhere from 1,000 to 3,000 psi. Right now, I'm going to be using propane, which will basically give me. It all depends on the main factor, but here's the math. I only need to fire this every second. So that's 60 times a minute compared to 3,600 times a minute for a engine running at 3,600 RPMs. So it gives you, 1,800 times a second compared to 3,600 RPMs. So that math should be very, very accurate on that. And plus we have the ratio of thrust with leverage, which gives me a roughly unbelievable amount of RPMs, but also torque. The maximum amount of fluid that I'd be using has been pre-calculated too. So I pretty much know where everything is at around roughly 1,000 psi. We're looking at close to 8 to 9 horsepower. And of course, we always have to do a loss of 30%. That's a good rule of thumb. I can explain the detail how everything is, but it's a little complex how the arrangement is. You can see I have an alternator here, which I can modify on the stator. And that would be, or the rotor itself, so I can control that power output. We have a 48 volt DC motor. So you see where I'm going? Actually, it would start with a battery. Once it's up and running, it's going to supply the necessary power to keep the battery going. Also be able to run the excess energy and that is through another method of around 1,000 watts of power I'm looking at on this particular design. 1,000 watt is actually a very good output. Even though it's going to produce around 2,400 watts, I need that other power to keep the system up and running. But we are using, now this is not over Unity. I am using the propane for the main drive system. And it's a little complex, but I've been doing this for many years, built many prototypes, modified so much stuff, and this is the real deal here. So what I got to do is basically go through the math, make sure everything's going. Everything has to be tested before I put it up and running. I want to try to get this rotating pretty soon once I prime it. And the air compressor down here is for actually the combustion chamber. And what that does, it barely runs. It doesn't need to run continuously. What that does is inject the propane into the combustion chamber. That propane then is mixed with the compressed air, around 150 psi. The detonation would be extremely high. That detonation then forces the fluid through the jets, like almost like a water rocket, and the rotation of it is extremely fast. The amount of power depends on, number one, how big my orifices are, or jets, and how many gallons I'm going to be moving. Now, this particular unit at 1,000 RPMs is roughly calculated around less than 5 gallons per minute, which is not bad if you do the math. But that's only at 100 psi, because it's the primer movement that I calculate. The other part would be far as getting that movement in there and then pushing it directly out. So this is pretty much an update on this new advanced version. I basically call it a hydrostatic turbine engine, and basically that's exactly what it is. We're using hydrostatic as a fluid to actually create thrust, almost like a water rocket. And this is pretty much the update on this particular model. I got a couple other designs I'm working on, but this is basically the small version. So basically what this is saying, if I could show 50% more energy output compared to the energy I put in for this motor, that 5 horsepower, you'd be lucky to get 3,000 watts of power, because you have a lot of losses involved. And most people don't realize that the horsepower takes 746 watts basically to round it off. But there is a loss in that also. So that's what I'm looking at. So if I can get even 25% efficiency, more efficiency out of that system, that is worth actually billions and billions of dollars. 50% is in the hundreds of billions. And the power system is it's not that complex, but everything in the process is very difficult to understand. Everything has to be proper. Each mechanical and valve systems and the explosions all have to be synchronized, which I'll have to program it, so I will have to do the electronics on this. And that's reading the RPMs and the output of wattage, input of wattage, what I'm using, and vice versa. So this is a update on a new version of the liquid turbine engine. I hope you enjoy the video.